Hello, everyone. Oh, wow. I'm Ruben II. If you didn't hear Ruben the First, he talked about compilers as well, and I'm going to go further into that. I think a few people here have tried to compile the program once, and if you are like me, I wondered what actually happens with the program from when I click F5 to whatever is spewed out. And if you've opened the file, you may think, what is this mess? Why is this shit here? And can I go back from that point after I've actually pressed compile? If I lose my source code, is there any way back? Because one thing we're going to look at is that compilers are actually just super advanced mappers in some way. And like 5 years ago, this was also complete magic to me. I still find this magic, and I wondered all the time, where do you even begin with taking compiled code and go back? Well, let's start with some simple code. This is in C, and it's just a function that squares a number. It squares the number 4 here, and returns that as the program value. Let's try run it, and we see it puts out 16, as expected. We're programming. But what actually happened in this transformation, all I did was like write some code, put it in a file, and output it to an exe, and then run it. But in between, the compiler did a massive ton of work. And if we try opening that file, what is this mess? What is this? If we try opening it in a hex viewer, it makes even less sense. This is just numbers and letters. But if we, for fun's sake, we always love meddling with numbers. What do they mean? If we look at this line, this specific line, and we try to change this suspicious B904 to B905, what will happen? Let's just try to run the program again. Whoa! Suddenly it returns something else. We changed program behavior without changing the code at all, which I find super interesting. Like, I at this point made a program that now outputs 25 by just changing some numbers. And how can we even understand what's going on behind here? Well, let's look a bit closer. This is a tool called Compiler Explorer. It lets you see what the compiler does under the hood. And of course, this is just assembly. Who wants to read assembly? It's what the computer is supposed to understand. But if we look closer at the numbers, we see there is a match in our file with whatever is out there. It's just like exactly in the file is exactly in there. And that's interesting to me. Because why can't I just take this back and make it C code, right? So cool, but what now? Does that mean I have to understand all of this assembly and painfully map it back to C? Yes, but also no, of course. There are tools, this is called Ghidra. It might be hard to see in the back row, but it's a tool that reads your binary and it tries to do the work for you. It tries to give you an immediate representation in C or C++, usually. This was made by the NSA, and I think they use it to do stuff that I'm not doing. I'm doing white hat stuff for this, I promise. But yeah, is it really this simple? No, of course not. It's never that simple. We, as developers, we make a lot of choices, both conscious and unconscious. And all of the choices you make affect whatever is coming out here, right? As an example, I could just, and you can't see this, but I could throw on optimization flags, which basically just says, run this code faster. So the compiler is way smarter with what it does to compile the code. And you see on the left side, that's what we had. On the right side, whoa, it just removed 60% of my program. It just did another mapping, but removed a lot of information because it was smart. And you can even see, if you're super good at reading assembly, it removed my entire function call. It just returns 16 directly now. And if we open this in Ghidra, you see it even clearer. This is before, this is after. It just returns 0x10, which is hex for 16. And to make it even more fun, it also removed all function names, everything that would make my life much easier when reversing the code for this. Yes. So what now? What can we do with this, right? How can I've just proven that I've lost information from the beginning, right? How can I go from whatever this is back to my original code? Because I lost intent. I lost my intent of wanting to call the square function. Of course, I could just create this function. Functionally, it would behave the same, right? It returns 16, but that's not what I promised in the description. I promised I could get back to the exact same code. And that's where the mentalism part begins, because at this point, I can't just imagine what happened or what's the output here? What does the compiler output? I have to actually get into the head of whoever wrote the code, right? My favorite thing when I started reverse engineering and decompiling stuff is I got stuck. I couldn't manage to get the exact same code. So I asked on Discord, as many people probably do when they're stuck, help, what can I do? And then Super Chad, in that, he's super smart, he came back to me and said, you can't just write it like you think. You have to write it like the programmer would have write it. You have to reverse engineer the programmer and then the code. And I was like, what the fuck do you mean? What are you smoking? But he does have a point, and this point goes further, in my opinion, than just reverse engineering and decompilation. Because when you go into a code base someone else wrote, right, you can't go in with the mindset, this isn't how I would have done this. This code sucks, I would do it another way. You have to actually go in and think, what time pressure was this developer under, right? He maybe had to cut corners to get to the point. He maybe had to do dirty things to get it working. Stuff I do, developers in 2001 wrote. That's completely different people. We have different mindset now than then. So we first have to get this whole detective act, like what did the developers do that wrote this application, right? So to go more into like a real world application of what I've been doing as decompilation, I work in decompilation for a decompilation of Super Mario Sunshine. That means we want to take the entire application of Super Mario Sunshine and get something that produces exactly the same bytecode. So it could be a representation. I can't guarantee it's the exact representation, but because of a lot of context clues, it should be pretty close. And we have a custom tool called object-diff. This was made by a community that decompiles. It just basically lets you see a lot of the symbols in the application and see what your raw code produces versus what is in the application. So it makes it really easy to see, did I do it correctly, did I not? So you can have a quick feedback loop of what's happening. And here you can see a specific function I've decompiled. Only 85% in this image, but it matches quite closely. But of course, as you see, a lot of instructions do not match. And this is all because of choices the compiler did of how I structure the code. So if we look at this, okay. I just wanted to explain the effect, and I added this right before. This is in Super Mario Sunshine. This specific function adds just a tiny blur filter to the game, just because I wanted to show the game, because I love this game. So yeah, and if we open the function in Ghidra, the implementation looks quite straightforward. It's just a lot of function call. If you've done OpenGL stuff, it looks similar. It's just instructing the GPU what to do. And I decompiled this basically by just copy-pasting from Ghidra into a file. And this is the closest I could get compiling at that point. That's the same output of 85%. This took me 30 minutes. Then I had to actually get the proper match to get to this point. And there's tiny differences, right? It's just I added a lot of float definition, makes no sense. I wouldn't have written it this way probably if I did it. But because of context clues I see in the order of the assembly and all of that, this is what I ended up with. Oh, nice, I lost one image. But I got from 85% to 99%. In this tiny difference of code. And if I were to move one of the floats to be defined 3 lines further down, it would output a completely different application. So everything you do as a developer has an impact. Like you have fingerprints in every code you write, in all the code you write. And it's even to the degree that I know some people who read assembly. I cannot read assembly. They do it. And they can say, oh, it was this person who wrote this code at around this time frame. And like, what the hell? That's insane to me. But yeah. So to summarize quickly, some takeaways from decompilation and some in general that I have from starting this. Decompilation is crazy time expensive. Again, 85% takes 30 minutes, 100%, 2 hours. We have decompiled 25% of the game, and it's taken 2 years. It might take a couple more. And of course, it requires, wow, I cannot spell. It requires insight and a lot of luck to just find what did the programmer think when he wrote this. What tools did he use? What insight did he have? What time crunch were he under? What corners did he cut to get there? So you really have to think about the person who wrote the code, not just the code. And that's all I had. Thank you.